Okay, here we are on page, I guess we're on page 26. Got this right. 9b. So there's another way to solve quadratic equations. Of course, there's always lots of ways to do different, to solve math problems. There's not usually just one way. So we're going to introduce you to a couple of different ways to solve quadratics. We did 9a. We solved them by factoring. We're going to solve them now by using the idea of taking the square root of both sides. So you guys know some square roots. I mean, some perfect square roots. The square root of 100 is 10. Square root of 9 is 3. But actually, the square root of 100 is plus or minus 10, and the square root of 9 is plus or minus 3. We don't often talk about the negative answer, but in reality, there are two answers here, because positive 10 times positive 10 gets you 100, but negative 10 times negative 10 also yields 100. So when we're taking square roots, there are actually two solutions, and we're going to use that to help us solve these quadratic formulas that we know, of course, have two solutions because they have a squared exponent for the x. So here's just a couple little notes. When we take the square root to solve these quadratics, this a, what's on the other side of the equal sign, has got to be positive because we're taking the square root of both sides, remembering that what we do to one side of an equation, we have to do to the other. And if this a were to be a negative number, you cannot take the square root of a negative number and get a real number solution. You'll learn about the square root of a negative number in Algebra 2, but certainly not in Algebra 1. So we're looking for this side to be positive, and we just talked about taking the square root of a number has a positive value, the square root, a positive value, and it has a negative value. So quite simply, if we just look at this first one, you need to isolate the variable. So x squared's alone. That's nice. We're going to take the square root of x squared, and we're going to take the square root of 9. So when we do that, we get x is equal to positive 3 or x is equal to negative 3. And those are our two possibilities. If you look at b, and I need to write this over here, isolate the squared term first. So this x squared is not isolated. He has got 2 attached to him by multiplication, so we're going to remove ourselves of the 2 by division. So we get x squared is equal to 16. And of course we can take the square root of both sides, square root, and we get x is equal to positive 4, and x is also equal to negative 4. Moving on. C, again, we need to add 7 to both sides to get the x squared alone, and we get x squared is equal to 13. Take the square root of both sides, square root, and we get x is equal to positive the square root of 13, and x is equal to negative the square root of 13. Because 13 is not a perfect square, you don't have to go hop on your calculator and figure out what the square root of 13 is. You can just leave your answer in this radical form for now. All right, let's look at D. He's got a number of things that we need to get rid of to get the x squared alone. Subtraction comes before in kind of reverse PEMDAS. Subtraction comes before the division. So we get 2x squared is equal to, what would that be, 36, divide by 2. And we get x squared is equal to 18. So when we take the square root of both sides, we get x is equal to positive the square root of 18, and x is also equal to negative the square root of 18. And those are our two solutions. I'm going to skip E. That's pretty straightforward. That's really like example A. And skip on to F. Again, first step is to isolate that variable. You're going to add 25 to both sides, and you get 4x squared is equal to 25. And now you're going to divide both sides by 4. So we have, let me get a different color going because I'm running into this problem. We have to take the square root of x squared and we have to take the square root of 25 over 4. So x is going to equal the square root of 25 over 4 in its positive form, which is 5 over 2, because those are both perfect squares, and the negative of 5 over 2 as well. So that one worked out nicely. Let's move along over here. We've got to get the x alone, minus 100. X squared is equal to minus 100, and this needs a big red flag, because if we try to take the square root of both sides, we would be taking the square root of a negative number, which makes no sense. You can't have a number times itself and end up with a negative square root. So basically this one has no solution. And technically, we'll say no real number solution, because when you get to studying imaginary numbers, you will have a solution to this kind of equation. But that's for another year. Moving on, let's subtract 5 from both sides. X squared is equal to 0. You can take the square root of 0. The square root of 0 is 0. So technically, we'd say, okay, well, x is equal to positive the square root of 0. And x is equal to negative the square root of 0. But both of those are the same number. So the two solutions are both 0. All right, we'll do a couple more, and then we'll end this video. So here we go. This one looks a little bit different, but it really is not, because the term that's squared is inside the grouping symbol. And you can treat this just like it was a single term squared guy. And you can take you say, okay, well, the squared term is isolated. That's nice. I'm going to take the square root of x plus 2 squared, and I'm going to do plus and minus the square root of 81. So that's good. The square root of x plus 2 squared is x plus 2, because x plus 2 times x plus 2 is x plus 2 squared. So that is going to equal plus 9, and that is going to equal minus 9. And we have to keep solving, because we're trying to find what x equals. So x equals positive 7. And the temptation might be for you to say x is equal to positive 7 and negative 7, but it's not. When you actually work this out, you get negative 11. So these are the two solutions for x for this particular problem. One more on this page. We need to get the squared term alone, which means we need to divide both sides by 2. We get x minus 10 squared is equal to 100. Take the square root of both sides, square root, and we get x minus 10 equals positive 10, and x minus 10 equals negative 10, plus and minus the square root of 100, which is positive 10 and negative 10. Solve for x, and we get x is equal to 20. And again, x is equal to 0. So don't make the mistake of getting the first one and then just putting positive and negative of that number. So our two roots, our two solutions for this equation are positive 20 and 0. Thanks for watching.